The slide's a little bit bigger.
Do you need to just advance the next one? It's not working.
Oh, there.
There it is.
All right. Thank you. So the project location for I-72, it's just east of Springfield. So Springfield sort of in the middle of the state. Springfield state capital, not Chicago. Figure on the right shows it's just a little bit east of Springfield. It's only like 20 minutes from my office. It's no easy for me to go out and watch construction, do inspections, anything I need to do. Design details for this project. Original pavement was an 8-inch continuously reinforced concrete pavement, built in 1976, so 50 years old now. It was constructed with decracking susceptible coarse aggregates. Decracking is a pre-thaw distress that afflicted many of our early concrete pavements in Illinois. It had an HMA overlay in 1998, and we milled that off prior to doing this new PCC overlay. The overlay itself is an unbonded 6-inch fiber reinforced concrete overlay. It used 4 to 5 pounds of synthetic macrofibers. The joint spacing was 6 feet by 6 feet. The eastbound had 1.25 inches of hot mix asphalt interlayer, and then the westbound had a geotextile fabric interlayer. There are no dowels in this pavement, so it's only 6 inches thick to mix a little hard to put dowels in. So kind of relying on aggregate interlock and maybe a little bit of contribution from the fibers for load transfer. When we had construction joints, like at the end of the day's paving, or we did it in 2 phases. So the center line, we were able to drill and insert bars for those joints. Average annual daily traffic in 2025, 14,800, 16% multi-unit trucks. So it comes out to about 800,000 diesels per year. A few slides here with the construction sequence for this project. So pre-stage 1, we had to replace the inside shoulder. It was only 6 feet wide. It was 11 inches thick. For the staging, that shoulder was going to be carrying traffic, so it was in poor condition, so we need to build and replace that material. For stage 1, we were working the driving lane in the outside shoulder, so we had traffic driving in a portion of the passing lane and then the inside shoulder. The contractor chose to do the driving lane and the outside shoulder in one operation. So if we had done the driving lane and then the outside shoulder, 2 separate paving operations, we would have had to use tie bars on that since we wouldn't have had the benefit of aggregate interlock. It would have been just a smooth joint. And since that's a solid joint, you kind of count on some aggregate interlock for that crack forms. We did a little bit of repair in the outside shoulder. We milled deeper than just the 3 1/4 inch overlay. So we removed all the overlay, and then the outside shoulder went a little bit deeper to repair some poor material in that area. And after the driving lane and outside shoulder were all done, we came back and paved the passing lane and the inside shoulder again in one operation. Just a solid longitudinal joint there with no bars. Some construction photos. So this is a photo of adding the fibers to the concrete. So they had the sacks of fibers. They just cut it down the middle, threw it on the conveyor, feeding the coarse aggregate into the mixture. The bag itself just kind of disintegrates as they're mixing the concrete, so you don't see the bag go anywhere. Once in a while, we did see a fiber ball. Pretty common, I think, in fiber reinforced concrete, but they were pretty rare. Just a photo of the fiber reinforced concrete. You can kind of see the little fibers sticking up in there. That's on the asphalt interlayer material. Contractor brought up the rating paper, you can see there. I just want to show kind of what it's like for working conditions under traffic. Most of you know, I mean, we normally will do crossovers on projects now for safety reasons. Does cost a lot of money to put out barrier wall and time to get all that done. This was also done during the daytime where a lot of work we're doing now is at night, but so you can see them in the worker, you're right there, your trucks come by, so a little uneasy sometimes when you're out there. A photograph of the geotextile fabric on the westbound, so the concrete industry really wants us to try the geotextile fabric. It's going to be less expensive. They don't want to compensate all their projects. So that's why we decided to split it by direction. And at first we were having them put it down with these washers and nails to try and keep it down. Very shortly they determined that that wasn't really going to work because you couldn't keep it tight and it would wrinkle up like this. Yeah, trucks backing up material to the paver, and then anytime they turn or break or anything else, it's going to cause that fabric to shift and move around. So I think it worked out better once they started using tack coat to secure the fabric, but still, one of the other things we could do with the asphalt interlayer was correct some cross slope issues that we had. So it's easier material to work with for the contractor, and then for design, it kind of was a little bit better for the district and the contractor. This is just the photo at the end of the first day of paving. That's at the very end, so let's cut that material off and form a construction joint. And there's a picture of construction joint with the, we think these number 4 tie bars in there just to get some load transfer of that joint. I think that's performed just fine. So some slides for the overall performance of this project. The OML uses something called condition rating survey, which is just a scale of 1 to 9 instead of 0 to 100. So starting out on the left is the performance of the asphalt overlay that was on there. And then at 16, we put the concrete overlay on, so that bumped it back up to 9. And it's still right around 8.0. The eastbound has some longitudinal cracking that the westbound doesn't have, so that's why it's a little bit lower CRS. I think that one's 7.8. And the other side is 8.1, but those are still in the excellent category for our CRS ranges. The smoothness trend for IRI, eastbound has always been a little bit smoother than the westbound. Again, the eastbound had the HMA interlayer, the westbound had the fabric. That had something to do with the smoothness numbers. They're both pretty good as far as IRI numbers go on concrete pavements. 95 is the threshold for the fence score, going from a good to fair IRI. So even after 10, 11 years, we're at 81 for the westbound, so it's getting a little bit rough, but still not too bad. I've got some more detailed information on IRI. So eastbound, driving lane, passing lane, both pretty similar. Both in the 50s, 60s range, pretty good concrete pavement. A little bump at the beginning where you transition from the HMA on either side to the concrete overlay. For the westbound, with the fabric interlayer, for the first half to 3/4 of a mile in the driving lane, there's a little bit of choppiness. So we see you're above 95 for a good number of those segments for the first 3/4 miles or so. And if you drive, it feels like a little bit of faulting on the panels. So there's no dowels, so everything interlocked and the fibers kind of deteriorate over time. So we're starting, even though you're sitting on something very solid, that the fabric and concrete below it, there's still just like a little bit of faulting that's going on. So our next step, at some point, we might diamond grind it just to get a little smooth. We did do manual distress survey, so we just walked the entire 3 miles of the pavement, eastbound, westbound, survey from the shoulder. For the eastbound direction, we have longitudinal cracks in the wheel path in some locations. These start showing up fairly early on after a year or two of traffic. And then they kind of flattened out. So 2020, we have 6.3% of the driving lane slabs had some longitudinal cracking. In 2025, we had 7%. So it really didn't increase a lot. The cracks increased a little bit on length, but not significantly. We haven't really had many that we've had to patch or do anything like that. If you're driving down the road, you don't really see it, but once we start looking at the down shots from our vans, we can pick them up pretty easily. And if you go out to do, like, the stress area was done in the morning, we had a little bit of moisture in the cracks, kind of makes it easier to see those. The westbound direction, the fabric had no longitudinal cracks, but it did have, for a ride, like I mentioned earlier, it did have some corner spalls, minor spalls that maybe 6 inches or less on each side. So 1.1% in 2020, 1.9% in 2025, so a slight increase. Just some photos there, the longitudinal cracking that we see in the wheel path. So a lot of times it'll be like the one on the left where you kind of see it's in both wheel paths, kind of lined up on either side of the slab. But then there's some odd ones where they're just going in one wheel path. Doesn't really line up on the two sides. And it's kind of concentrated in one area of the project, like the first mile or so, and then the further you go along, the fewer cracks you see. Some photos of the cores that we took. So the westbound there with the fabric, the cores come out really nice. It's easy to remove the core with the fabric inner layer there. Sometimes it'll stick to the concrete, sometimes it'll be left in the bottom of the hole. But for the eastbound, we were really taking cores to evaluate the condition of that HMA inner layer to see if there was any damage. So we took cores mid-panel. The HMA was bonded to the concrete in good condition. We took cores 6 inches from the joint. The HMA was bonded and in great condition. Then when we took cores like over the joint, particular joints that had that longitudinal crack, you could see that there was a little bit of erosion and stripping in the HMA inner layer, debonding. So you lose just enough support there, cause just enough deflection to sort of initiate that longitudinal crack. Following downward testing of transverse joints. So this is showing the load transfer efficiency across the joints. So the red squares are from 2016, so that'd be just a year after paving. So you still have aggregate interlocks, still have the fibers, I guess, mostly intact. We have pretty high numbers actually for load transfer efficiency, especially with the HMA interlayer. The fabric, the LTE values were lower. So you kind of get some conflicting data when you start digging into things. 4 years later, it deteriorates a little bit as far as lower load transfer. Then by 2024, 8 years after construction, or 9 years after construction, lower values and kind of a lot more scattered in your data. And the westbound with the fabric just had a lot more scatter from the beginning. Higher deflections, lower load transfer efficiencies. So even though there was no cracking, there was some other data which made it seem not quite as good. Lane shoulder joints, kind of the same thing here. It said since they paved the driving lane and the shoulder at the same time, there was no bar there to tie them together. So it's just aggregate interlock that's all net together. So by 2024, you pretty much lost your load transfer. Not really a lot of separation, but a little bit of faulting where the shoulder was higher than the lane in some locations. Especially on the asphalt side, I think maybe you lose a little bit of material or might have stripped there because water could get into that joint. Ultrasound tomography with the MnROAD device. So this is a little shoebox sized device that we can use to shoot a signal down into the pavement and see how it bounces back. So with the westbound, with the fabric, there's kind of a cleaner break between the materials. So you have a stronger signal there, 150, which is a 6-inch thickness. On the side of the asphalt interlayer, the concrete is bonded to that layer, so it gets a little bit fuzzy as far as the reflections coming back, being read by the MnROAD device. And this, I think, is just showing you can see a much more clear signal on the side of the fabric there on the top than you do on the side of what the HMA or layer that we showing on the bottom. We did do a few patches in 2024. The location on the left is a transition panel from asphalt to concrete. That panel cracked. I think it's left of that. That panel cracked within a year after construction. The nice thing with the fiber reinforced concrete, sometimes even when you do have cracks, the fibers kind of cracks tightly together. So it wasn't a huge performance problem. We kind of let it go for several years before we patched it. And then if they had asked me, I would have told them they could have just patched the 6x6 concrete, but they did a full depth patch there, so it's like 6 inches deep. So it's like an airport runway patch in that location. And they didn't even bother reestablishing the joint in the center line. They just did this one rectangular patch, but it's so thick, it's still performing fine. The one on the right, those are two consecutive panels on the right wheel path. Again, they didn't reestablish the joint in the middle of it, but it's still performing. And there's 3 patch locations in the eastbound and 1 in the westbound. 11 years, so really not much going on there. So overall observations, both the eastbound and westbound are performing well after 10 plus years now. It was designed for 15 years. We typically expect 15 years out of an HMA overlays, and we designed this for 15 years. It's going to go far beyond that. Performance, as I mentioned, fabric inner layer, you have less surface distress, but there were higher deflections, and the ride quality is worse than the eastbound with the HMA. HMA lower deflections, but more surface distress as far as the wheel path cracking. And as I mentioned, the lane shoulder longitudinal joint, there's a little bit of faulting there, so that's another area we can grind to correct that. Some of the recommendations from the researchers, install tie bars at the lane shoulder joint. If we stage it differently, we would have had bars there, we would have had better load transfer across that joint. Improved surface drainage. I think it's 2% cross slope, so if you have a little bit higher cross slope, help get the water off faster. And seal the longitudinal lane shoulder joint to keep water out of that joint. Second project, I-57 design and performance. This would be a more conventional unbonded overlay design, so it's not the thinner slabs like we did on I-72s. This is more thickness that you can see on the typical jointed concrete pavement. It's down in Johnson, Union counties in the southern part of the state. The original pavement was a 10-inch jointed reinforced from the early 60s with 100-foot joint spacing. Almost more of a CRC state for the interfaces, only 2/3, but some of the pavement, about 30% or so, was jointed reinforced back in the early years. So those are the ones basically every 100 feet. There's the problem because those joints would always fail. Some of that stuff got rubblized, but then we did concrete overlays on this particular project. So that was reconstruction 2016, 9 3/4 inches unbonded JPCP overlay. So this project had one HMA overlay at the time of construction. So instead of completely removing and replacing that, they kind of used that material as the inner layers. So they just did a profile mill, took off 1.5 inches, put back 1.5 inches surface to serve as the inner layer on that project. Project limits for north and south were a little different, longer in the north-southbound than it was in the northbound. And then just in the last couple of years, they came back and sort of filled in the northbound section to match the south. They didn't have that money to do the entire project. I had to break it up. It's a standard 15-foot joint spacing lift out bars. They do have load transfer devices here. Traffic varies from 11.7 to 15.9 for total ADT. Truck traffic much higher, over 50% in use, proportion of it, and 40% for the remainder. CRS trend for this project. So again, on the left, you start out with the condition of your HMA overlay. It got down to 4.5 or so, which would be in the poor condition, especially for an interstate pavement. Put the PCC overlay on in 2016, and it's been pretty steady since then. The IRI numbers, this one, smoothness is not quite as good as it was for I-72, but it's also been pretty steady over the years. Not getting worse over time so far. Observations and recommendations. So this is almost 10 years old now. It's no significant stress. For the traffic volume and existing condition, jointed plating concrete overlay is recommended for help reconstruction because it's really not a rehab. It's basically building a new pavement on top of the old. As far as this research study, since they were doing work on the northbound lanes, we couldn't close down any of the southbound lanes to get out and do FBD testing or flooring or any of that work. We're going to try and pick that portion of the study up this summer. So the work is done now. And then the last project is East Grand Avenue. It's a town of Greenville in southern Illinois. So this one was constructed in 2019. This was a local project, so a city project, not a state project. The original concrete pavement was 16 feet wide. It had been widened with bituminous and overlaid, like about 20 feet. And the plans were to come back and put some additional widening, and then like an additional 4 or 5 inches of asphalt. Make it a more conventional, like 11-foot wide city street. The contractor submitted a value engineering proposal to us to just wipe out HMA overlay for concrete overlay for the same price. So we don't normally do that. We agreed to take it on as an experimental project because we thought it would work. It just wasn't what we had originally intended. So it's about 6 inches thick. The 2 lanes now 11 feet wide each. Joint spacing is 12 feet on this one. They incorporated a concrete gutter along the edges there. Total length is only about a half-mile section. ADT 3250, mostly passenger vehicles, buses, garbage truck, that kind of thing. So not many heavy trucks. So last year we walked the entire section and did some air testing on that as well. It's a warm day. We're out yesterday. Picture on the left, just some joints falling, which is probably this early sawing on there. There were a few cracks that happened. One second from the right is more likely just a late socket or something that cracked on the stone there. Some other, a few cracks here and there. That all appear within a year after construction. I would consider these more construction defects than I would actually load related distresses. So there's the photo. The section is actually a very nice section now. I'm going to the neighborhood. Section just to the west is still the narrow asphalt pavement that's on it, 20 feet wide. So it's a improvement for the homeowners in that neighborhood there. Like I said, no design and performance issues so far. 6-7 years old now. Just a few cracked panels there. Like I mentioned, the most likely construction defects or light sawing or something that caused those. The overall recommendations from the study: continue to design and construct concrete overlays. The price of the company. For the unbonded concrete overlays, like on 72, the 6-foot by 6-foot by 6 inch design worked well. That's sort of what I would call moderate traffic section of our interstate system. It's not super heavy, but it's not really light. So would we want to push it much further traffic wise? I'm not sure. We need to do a little investigation to see how much We need more trucks would be willing to put on something like that. Once you get above a certain thickness, and we're 6 inches here, once you get to 7 or 8, then you kind of a more conventional concrete pavement. 6 inches and below is kind of where we'd be at for this 6x6 design. Macro fibers, very helpful on concrete overlays. So they maybe provide a little load transfer, but the main thing is they kind of help keep cracks tight when they do occur. I use the tie bars on longitudinal joints to be helpful to prevent faulting. You've got a load transfer at that location. The section with the geotextile fabric is performing just as well. It's a little bit rougher, but doesn't have any cracks. I was really hoping for a clear winter. Have HMA overlay great, textile not great, but it's kind of a mixed bag here. They both perform pretty well overall, though. It's an HMA interlayer. Main problem was the longitudinal cracking from some stripping at those joints. So if you seal all the joints at 6x6, it gets to be a lot of sealing. We've done a lot of concrete pavements with unsealed joints that perform just fine. So the concrete industry doesn't necessarily encourage it because it's going to increase the cost of their product if we were to do that. So overall, I'd say given the performance, it hasn't been an issue. Especially the lane shoulder joint, it's pretty easy to seal now, keep some of the water out of that joint. Just a list here of some of the various concrete overlay products that we've done with it. So we've done quite a few over the years. I think there's some work with fibers, and we built some sections, both the mainline and low volume road in the first construction phase. Some of these projects I was a panel member on, some not. So the one on test section repairs, performance and engineering mission, the diamond grinding. That one's done now. Oh, okay, so a couple of these are ongoing. I think the bottom ones are finished and the top ones are still ongoing. And Tom kind of pushed the limits on thickness on some of them. So we had some 3-4 inch sections in 2017. So definitely checking out the performance of concrete overlays. So that's all. I'll be glad to take any questions. And again, there's a QR code if you interested in looking at the report.
We have time for 1 or 2 questions. Anyone have a question, Charles?
Do you know if there was like maybe the options with and without the fabric, which was more expensive, was it easy to install?
I'm sorry, which?
I meant to ask like which is the more economical option between the fabric versus having an HMA?
Definitely the HMA side would be more expensive. And the fabric is less expensive. I don't have the exact cost, but I did speak to the District 6 materials engineer asking why they weren't doing more of these, and that definitely was a factor. But the fabric is, like I said, more difficult to work with as far as trying to roll it out and keep it down in one place. And like I said, you can't correct cross slope the fabric like you could with HMA and the left. Another benefit.
You know what type of fabric?
The non-woven geotextile, I think it's a Protex material. I used to have a sample somewhere in my office, but we're moving offices, so like all my stuff is in boxes. I couldn't find it when I was coming. I do have a sample of the fibers, but if anybody's interested to see what the synthetic microfibers look like, but I couldn't find the fabric. Anyone else?
Along with the fabric, like the integrity of the concrete looks better compared to the one with the HMA. Is that a good interpretation? I saw more cracking and more
I'll pick my side down once I go back. Okay.
So my question to you is that you think that they probably will accept having a rougher, let's say long term, like a rougher ride, but having a pavement that lasts longer and you don't have to do record. Or do you think people will be open to a rougher ride, but maybe longer performance?
That's a good question. I mean, the good thing is even though the westbound is rougher, it's not like it's extremely rough. So like I said, even though we have a few panels there. You want to see the cores?
Yeah.
Okay.
Yeah. Look like the cores look like the one that have like the fabric look like more solid, like more, the integrity look much better than the ones that we have HMA. I don't know, is that a good fair interpretation?
Could be, but maybe just like this particular core. Overall, the concrete material is fine for both directions. It's the same mixture exactly.
Our experience with geotechnicals working with blue fabric makes everything more uniform, stresses distributed better, everything's like more uniform, so that's why I kind of, maybe I have bias with it so far. That's why I'm like seeing the fabric look better, sorry.
I guess I was a little surprised too, that the side of the panel would be different side-wise. I mean, it could have been something. It's from like the beginning of the westbound for the first half and 3/4. So it's possible that there could be something with the mixture that they tweaked a little bit as they were going along. Or it could be something with the fabric. Like I showed those pictures where it was bunched up and things, some construction issues that caused the roughness. Because it was rough from the very beginning. It was getting a little bit rougher as time goes on, but I think that could easily be corrected with diamond grinding.
As far as fabric, some of the things we consider is the fact that you have no bond. So some of us are thinking perhaps there's much more curl, and that's going to affect your ride. Also, when you're doing FWD measurements, you get much higher deflection because the fabric compresses. So that kind of artificially makes your joints not look as good. We have to move on, so take your question afterwards. Thank you. All right, thank you, Charles.
Yep.
Okay, our next presenter is Julio Paniagua, and he's with CPS Cement. He's the Director of Pavement and Infrastructure. And he's going to be talking about the experiences they've had kind of playing around with their materials at MnROAD over the many years that they've been involved. Thank you.
Thank you, Tom. So yeah, my name is Julio. I'm happy to be here. I'm going to talk a little bit more about concrete, a little bit of science, and a little studies that we have done over here. The first part is with the fundamentals of the systems. Then we will go on the discussion of what we have done in the past and recently, and then what's coming ahead. So calcium sulfoaluminate cement was actually invented in the 1950s by Professor Alexander Klein, but it was originally intended for shrinkage compensating cement. But it was not until the 1970s that they tweaked it to create a fast setting cement. The main characteristics is this is a standalone cement. This is not Portland. There's no calcium alumina on it. There's no mineral additives. There's no chemicals. There's no anything. It's a cement that by nature is fast setting. Depending how we play with the raw materials, then we fall in a different category of CSA cement. Today, we are talking about the Belitic calcium sulfoaluminate, the blue one, and that's the fast setting cement. I'm going to try to share a few literature through the presentation. The CP Tech Center released this tech brief at the end of last year. I think it's a really good document that goes over the technology, over the system, and I thought that it was worth to share. I'm not going to spend a lot of time in chemistry, but I think there's two main things that is worth to highlight. That is the yelemite and the bilite. The yelemite hydrates when it touches the water, hydrates into the ettringite. And it's that needle-like structure that grows really fast as soon as it touches the water. And it interlocks. And that's what creates the matrix structure to give us strength at an early age. And then the bilite in small quantities and a longer term is what develops the strength at a later age. There's these 5 characteristics about rapid set or BCSA cement. Is the higher the strength, depending how the mix design is done, We can achieve 3,000 PSI as fast as hour and a half to 2 hours. Really low shrinkage, at least 20% of comparable OPC mixes. Silica reactivity is really low. Sulfur resistance is really good because the material do not include C3A like Portland cement does. And then the sustainability, is not a topic nowadays, but again, it's 67, 69% of OPC. There's a proven industry published EPD values for all this. So the first section of pavement was built in 1963 in California. Sections of those two projects are still in service, not all of it. But it was not until 1994 with the Northridge earthquake that rapid strength concrete in California took off. Two overpasses collapsed. Caltrans needed to build the ramps, the access ramps, and they relied on the research that was done at that time, and they decided to use BCSA cement. They opened the project 74 days ahead of schedule, and from there, it has not stopped. Since 1994, 95, there's more than 2,000 lane miles of BCSA cement in California. It's definitely the state that uses the most, but there's also many other states that use it. Main applications is highways. I purposely pick those three projects or those three pictures because it shows a slab replacement, longer stretches, different type of pavements, heavily reinforced, but the three of them are produced with ready mix application, and we are going to talk about that in a minute. Bridges, bridge deck is pretty common. This is a material that is less permeable, so it's really good for corrosion. We do a lot of bridges. And the third main application is airports. We do a lot of airports. This material is used when you need a speed. If you don't need the speed and you can afford closing your pavement for multiple days, go use that. Use Portland cement. How do we deliver concrete into on-site? Two methods. Volumetric truck. Most of the people think that that's the only way, but ready mix is pretty common. Nowadays, like 65% of the projects go volumetric and 35% of the projects go ready mix, especially those ones that are larger volumes. Both methods has their pros and their cons. The reliability, consistency, efficiency of the ready mix those are the highlights. But then in the volumetric, the versatility to adjust things, stop and go, it make it desirable for contractors. But it is done in both ways. I just came from Seattle, but we were there on Monday night, and they are just rebuilding sections using ready mix with a holding time of about 35 to 40 minutes, and that's pure rapid set. It just depends on the mix design. There's the engineering behind the mix design to optimize the mix according to the delivery method and the project needs. These two mix designs are for exactly the same project, exactly the same performance parameters. It was designed first for ready mix application. The contractor switched later for volumetric. This was in Wisconsin, but it's exactly the same project. We will just, or contractors or engineers will design the mix accordingly. Okay, that's kind of the fundamentals in case somebody want to go back and review the slides. Now we're going to get into what we have done on MnROAD, and it's basically three projects in the last decade or so. The first one in 2011, then 2017, and the most recent one that I was heavily involved in 2024. So the first project in 2011, the sections built in 1993 start to have severe distresses in the joints, and in order to keep the service on those pavements, MnROAD was obligated to do some repair in those joints, and they decided to do a partial depth repair program. I don't think there was an objective of ranking the different products, but just understanding what was in the market and how they perform. Two pictures of how the pavement was looking in the centerline joints and in a transversal joint. The system was ranked from 0 to 5, where 5 was an excellent condition after 3 years, or every time it was analyzed, it was reviewed every year for 3 years, or 0 completely failed. We or CTS or CSA cement was used through this product, which is a DOT repair mix. It's a high performance structural repair product. Is highly percentage is CSA cement with some polymers with sand that improve the permeability, that improve the durability of the mix. It can be used from 1/2 inch to 24 inches if it is extended with big gravel. Really high early strengths, 2,500 PSI as quick as 1 hour, and easily hitting the 7,000 PSI at 24 hours with really good resistance for scaling and freeze and thaw. That's some example that I extracted from the report. Joint 120, 132, those are the 4 pictures of the 4 different evaluations that were done. It performed really well. Most of the joints got a score of 3 or 4. There's a couple of them that got 1 or 2, but most of them got a 4. Those pictures, I don't think you guys can see it, but there's still tiny cracks. Most of the cracks are in the direction of the joints. Very likely the joints were not honored, and of course the crack is there, but it still performed really well. Then second project, 2017 in the westbound of I-94. This was a more structure intended project, sections that were built in 1973. So all the distresses were manually done. And the idea, they didn't traffic it during the winter, right? Only during the summer. This is a layout of the distress in each of the 15 sections. And we participated with, again, with DOT a repair mix. It was done around fall of 2017, and it was evaluated every year for 3 years. And again, it was ranked from 0 to 4, where 4 was completely damaged and 4 was perfect conditions, and 0, it failed at some point in the process, and it had to be replaced. I just said that the same product was used, and a couple of variations of this product with fibers and no fibers, but that's the system of CSA cement that was used. So we can see in the picture in the right side, not intended to compare versus other product, but just the final score after 3 years, I believe is in the 3.7, 3.5. It performed really well after 3 years in service. It was categorized as a long-lasting patching repair material, so we were happy. This pavement was built or was reconstructed in 2025, and Tom was really good to share some pictures that were taken in 2025. So the same section, the same patches that were built in 2017, from the set of pictures that I got, really good condition of most of the patches. Some of them, like in the middle picture, yeah, it didn't do well, and it was patched with something else at some point in the process, but really happy to see how the durability of the material. The last picture shows fibers. I don't think I have the time to go into a lot of details, but one of the myths is that there's more corrosion with CSA cements, and that's actually not true. It's a more dense material. So the fibers, according to the report, that were embedded in the concrete and not exposed to air and water, show no corrosion at all. And then the third project is the low volume roll cell 2437. So in fall of 2024, MnROAD had this project in which they used multiple low carbon cement alternatives to test it, right? We were not selected initially, mainly because we cannot place PCA cement, rapid set cement to a pavement. But around, I don't know, I remember like November 10, November 11, we got a call that there was a situation in which one cell was already open, and due to the change of weather, it became really cold. They couldn't place whatever they were intended to place, that what if we could do something. And oh, by the way, it needed to be done before Thanksgiving. So literally like 12, 13 days. So the challenge was not only Thanksgiving of 2024, the freezing temperatures that were already over here, but also none of the contractors and producers that traditionally use rapid set in Minnesota were available, or they were already shut down for the season, or they were working in another South state trying to finish before the weather chased them, right? So we have to find a producer and a contractor that have never worked with rapid set before. We develop a mixed design with the targets that we were asked for, higher needed to be placed and needed to reach a strength to be able to have it in service for the winter. SGV Concrete was the producer, and North County Concrete was the contractor. We flew in, we helped the producer, we helped him calibrate the material, we helped him calibrate the mix design. We did multiple trial batching. That trial batching by itself is a must in any pavement project, but we definitely did a lot of that. And we made sure that we had a good concrete. Then the next day we met with the contractor to start Every new contractor that do concrete, they know what they are doing, right? They are super smart. They always know what they are doing. Oh yeah, we can do it. It's easy, right? And then when they had to assign more people because they were falling behind of how the material was setting, it's like, oh, what is this, right? But they learned on the spot. They had no option, right? Their ego came down really fast. The left picture is how we found this section the day before, the afternoon before, a little bit of snow. Second picture shows the weather conditions during placing, and then the other two show construction. In the last one, we can see how we are roller screening the last end. The finishing crew is already halfway finishing it, right? And then in these ones, we can see the finishing crew is in one end, and then the timing is already halfway. That fast it was going. We had to be very aggressive with the retarder because otherwise it will not reach the temperature that we needed and the strength. Right away, curing compound. As soon as it became not sticky, curing blankets. And even when we did the sock cuts, it's not that we opened the entire surface, right? We just open enough to do the sock cuts and cover it again. You guys can see the results in the report that Dr. Bernard wrote. Very extensive and good report. But we were really happy with the fresh properties, right? I mean, 5.5 inches long. It was a really workable mix. The crew didn't struggle. Air content of 7%, where the target was 6 or 6.5. And then temperature of 63. That's key, right? Because that's what the material needed. Weather was at 33, 34 degrees, and we discharged at 63. Hot water was used. We conditioned the truck inside a warehouse the night before. Therefore, the aggregates were trying to be removed from the outside. But those are common strategies that are used when the weather required it. The 4-hour compressive strength was 3,800 psi, which we were really happy to get those strengths at weather conditions, and the same as the flexural. The flexural trend, there has a dip at 28 days. I wanted to be honest and put it. That's a phenomenon that we see more often than what we would like. It's not a material issue. It's a more like a manipulation, curing of the beams at a later age. Usually they are not treated the same way. And that's why we always do compressive strengths along the beams, because the compressive strength at least shows the behavior of the material. Shrinkage, I didn't even put the plot because the result at 28 days was 0.009% per ASTM 157. Literally nothing. Resistivity values, it fits really well in that chart where it shows almost very low susceptibility for chlorides, and the durability, it performed really well. I mean, we didn't run all these tests. Minnesota hired, I believe it was AET or something like that to run all this testing. And the results are available. So very pleased how in a matter of 12 days, we were able to put a mix design, a producer, a contractor, and build a section that still is in place, and it will be there for as many years as MnROAD needed. Okay, but what's next, right? What are the next steps? Where do we want to go? Where this material can go, right? And it's basically innovating with the PCSA as an additive. We all know about PLC, right? OPC with extra limestone. Yes, lower CO2 emissions, but we can have a big discussion of the reliability, one-to-one comparisons, strength issues, etc., etc. That LC3 is another option. It's another type of OPC with modern modifications to even further lower the CO2 emissions. But what about performance, right? I mean, 56 days, etc., and all that variability and issues that we see on the field. So can we enhance PLC, LC3, or alternative OPC materials with PCSA as a mineral admixture? We believe we can. We believe we can, and this is not a belief. It has a process of more than 4 years at this point. There's multiple publications. You guys can access them. The links are there, and there's a few more. There's multiple publications in the last 4 years of what us and multiple research teams around the country, especially UCLA, has put an effort on this to see how can we improve alternative cements. The principle is basic, is easy to understand, is changing the balance, the chemical reaction. So we start from the cement chemistry, how that is affected from XRD, XRF, TGA, calorimetries, all this, how those sulfate balances, the carbo aluminums in the mixes change it by adding PCSA. The plot might be a little bit complex, but maybe we focus in the blue thread. The blue thread is the LC3 by itself. And in the moment that that's the dash one, in the moment that we add BCSA to it, is the green curve shift completely. So not only the BCSA provides early age properties, but it enhances and accelerates the reaction of the alternative cements. Next step was mortar. And this most of the work was done by Elizabeth at UCLA, her doctoral dissertation. And she found like, okay, this PLC, LC3, they don't have any early age strength. But as soon as BCS is added in certain percentages, early age strength is achieved. We went to concrete, and now we were able to bring these systems to be able to compare them with OPC type 3 or even BCSA by itself. Now we bring them up from being far of that performance to at least put them in the same arena. The right plot is carbon intensity. I wish I would have more time to talk about it, but when we talk about low carbon cements, yes, we can achieve low carbon, but then we are achieving a strength of 56 or 90 days. We believe that the low carbon should be compared at the time that concrete is intended to be in service, right? If it's 28 days, perfect. If it's 56 days, perfect. But if we are using these cements at an earlier age, we need to compare them at the time of service. So it's basically a GWP divided by a strength unit and by a unit of performance. And then the difference are massive, right? Because BCSA is not only really low carbon, but it achieves really high strengths and really good performance at an early age. That in order to achieve the same with alternative cements or OPC, the amount of additives and cement content in a cubic jar will increase. And by the time you divide that by the strength at 4 hours, which is probably not that much still, the difference is massive. Okay, the next step was pilot projects. We built one in Southern California in conjunction with the Caltrans district over there. And then we did another one at UC Davis Pavement Research Center, part of the Lab to Slab initiative that they have with Caltrans. Then on the Oregon State University with Jason Rice. 3 main pilot projects that have been in service for anything between 6 months and almost 2 years now, being monitored, being categorized. Precast application is something that we're looking for. So a few pilot projects in the Northwest, Mexico, and even Abu Dhabi with NYU. This is a picture of the construction of the 2 cells at UC Davis. One is the PLC2 that we call the PLC plus Belite calcium aluminum, and the LCX, that is the LC3 with BCSA. Normal pavement, it performs great, but we just have the early age performance. So what are we looking for? Just to conclude, it's an opportunity to bring low carbon alternative systems based on BCSA to MnROAD in one way. Compare the performance with Caltrans and UC Davis stat sections. I live in California, but I'm not originally from California. So they said that they have the most severe weather for pavements, for concrete pavements. And then Minnesota has also really harsh conditions for concrete pavements. So the idea to compare a thin section in MnROAD is very attractive and provide all that data to DOTs. There's a few DOTs already, Wisconsin, Oregon, Washington, California, that are highly interested in these systems. But by participating in something like MnROAD, that the outreach will be a lot more. Rapid Cities production out of ready mix is 100% doable with no questions about it. That's my last slide. CTS has been producing the liquid CSA since the 1970s. In the field of low carbon cement, is the only low carbon cement that is categorized as a TRL9, and that's massive. And it's the only cement that will provide high early strength, that will provide low shrinkage and proven durability. So if there's any questions, I will be happy to take them.
Okay, I'm gonna start off with maybe a little bit of awkwardness.
Sure.
And you didn't really cover the fact that when we did that still on the low volume road with their mixture, there was some funky testing results that came out and a little bit of controversy. Do you want to cover that, or certainly Bernard can cover that?
I will probably have Bernard cover that. I mean, and we talk about this. I believe it was the freeze-on thaw The freeze and thaw testing, is that the one, right? The one that we requested a different curing?
This was very interesting that we, sometimes apply standard testing to some of these materials that may not be suitable.
Yeah, correct. And just before Bernard jumps in, we did a really, we think a really good presentation on HCI spring of this year, and that's a challenge that we face, and we meaning BCSA, right? I mean, BCSA is a C1600 cement, it's not a C150. So all the tests are designed and were designed per Portland cement, and we believe, and we have tested enough that a lot of these tests should not apply the same way or should not be done in the same way for alternatives and low carbon cements. And not only BCSA, I mean, alternative cement itself, like these tests were developed for that. So I believe the test in mention is the freeze and thaw that we requested to do a different curing protocol. Was that?
Well, I would just say summarily, we did typographic analysis using a local consultant, and some of the products that we're finding were not necessarily what you will see the Belletic calcium sulfur aluminate cement concrete. But that's because the protocol for the typographic analysis was based on Portland cement. So even though there was no daylight, they saw yellowite and they probably misinterpreted it as daylight. And so those are the kind of things that data brought to TRT and said, well, when we have these new products, we should probably be looking at ways of evaluating them. Now, this product passed the ASTM 666, very significant. In spite of the fact that it was placed under very severe, temperature conditions, and it passed the durability test, and that was amazing. So, but we did the petrographic analysis, and they said, well, there is a particular product, but they couldn't name it. So that most likely to be yellowite, which is the basic product.
Yeah, that was the. I didn't have time to go over it, but definitely nothing to hide. I mean, there's multiple discussions at ASTM, ACA level. The freeze and thaw was another example that we requested to do two set of specimens, one cure for longer and other cure the typical 14 days, because again, the matrix, even though it develops strength at an early age, the matrix do not mature as quick as the OPC. So, but there's a big discussion about that.
No, thank you. That's the point you made, is that we have to be careful about the test methods that we have been using for PLC for 100 years. We're gonna have to reinvent a lot of those for some of these materials.
I agree 100% with you.
Any other questions for Julio?
Awesome, thank you.
All right, thank you.
Before we did the freeze-thaw testing, and we talked about modifying
Correct.
the protocol. We didn't do it both ways. We did it with the modified protocol, I think, because of limited concrete.
No, there in freeze thaw there was two test sets. One with the 14-day of you sent it to me, so I know.
Well, then you're right.
I have it in.
Tool that's used to finish it, to level it off, or could you use a truss screed or other screeds that maybe have higher vibration impact?
You definitely can do it. Contractors use it, but definitely roller screed is the preferred method. The slump is relatively high, so they usually don't struggle. It's more to push the rocks down, bring that pace up. So definitely the extra vibration and energy most of the times is just not needed but it can be used, definitely not a problem. Not in a paper, right? Not in a slip-form paper. That's another game.
Thank you. All right, our next presentation is going to be a renewal one. We're going to have a shared team here from some colleagues here at the Office of Materials and Research. We have Dr. Ceren Aydin giving the first part, and then it'll be Dr. Bernard Izevbekhai for the second part. And they're gonna be talking about contemporary applications of AI and materials and paper research, and I kind of want them not to throw too many equations, because I see they changed their titles, so maybe it's been mellow, thankfully, I really appreciate that.
A little bit. All right. Well, it's almost 4:30. That's the last presentation of today. And I look at the agenda and I saw that this is the 15th presentation of the day. So because of that reason, we really wanted to give you a lot of equations, a lot of theoretical background. So just kidding. We thought, okay, we know that we're going to have a little bit of tired audience. So let's look at things a little differently. We have a really fancy presentation name, Contemporary Applications of Artificial Intelligence in Materials and Payment Research. But what we're basically going to do is actually showcase you how we have been using AI in our workflow. So you can get inspired, or we can have more discussions with you so you can inspire us too. So first part of the presentation will be given by me, I'm Ceren, and later on, Dr. Bernard will take over from me. So AI is such a loaded word. It's sometimes really difficult to understand what you mean by AI, but it could mean many, many different things. And, machine learning, deep learning, generative AI, large language models, Copilot is one of them. I can't say ChatGPT because that only allows for Copilot, but I said it already anyways, or cloud. All these are subsets of artificial intelligence, and we're gonna, when I refer to AI in my presentation, my part of the presentation, I'll be referring to these different things at the same time. So we thought let's take a look at the history of AI, because it became really, really popular recently, especially with the large language models. But there's definitely more than the large language model part of it. And we're going to take it all the way back to the 300 BCs with Aristotle, okay, really going all the way back from 300 BCs. He's, I think majority of you know him, he's a Greek philosopher, but he is the first person who formalized the logic and structured reasoning, which is, those two concepts are actually foundational to AI and how machines actually think. And we're going to fast forward. And my part of the presentation also will have some fun facts regarding the brief history. And when I was doing my research for this presentation, I've seen that there are other websites having little or slightly different than this timeline, but more or less they're very similar to each other. Just a little disclaimer over there. So we're going to jump forward the 18th century, and we're going to take a look at this very important, and that might be the only equation in this presentation, okay? So Bayes' theorem, it's really important because it's all about probabilistic reasoning. Maybe it's not exactly what all these large language models are doing right now, but they are sharing similar philosophical background in terms of updating the belief or training these systems to get a better reinforced or reinformed data output. And then this fun fact, I really like this one. So this is the first literature regarding AI. Mary Shelley's Frankenstein from 1818. It's one of the first fictional, of course it's a fiction, but it is, I think, almost all of us probably know the story about this. So it is where the question, several questions asked for this story, right? Of creating some intellectual being other than humans, would they pose bad situations, or who's in control, who's responsible to create this intellectual beings? And when you actually think about them carefully, maybe they're not applicable what we are doing in our civil engineering world, but it is to me fascinating that the questions they pose, whether intellectual beings are good or bad, are still relevant to our age. So there are still people thinking, is this going to be really bad for the Homo sapiens, human beings or not? So they ask those questions. She asked those questions way before us. This one, especially this one, this deserves maybe more than an hour discussion. This legendary person, Alan Turing, he is the first person who asked, can machines think? And he came up with something called the imitation game, later known as the Turing test, which is a tool, which is a test for you to differentiate or for you to understand if you are talking with an AI, if you're talking with a machine, or if you're talking with a human beings. So this test used to decide if AI is showing some capabilities to replace or answer as like human beings. But not because he's really, brilliant scientist, obviously. In 1950, he was asking about AI and, can machines think concept. He's actually a real life hero. So credit will go to Raul here because he reminded me that, there's actually a movie about him called The Imitation Game. It's a great movie. So this person, Alan Turing, this brilliant scientist and his team actually were the ones breaking the Enigma, which is encrypted communication system used by Germans during World War II. So they saved more than millions of people and they shortened the duration of the war. So when we look at him, we're not just looking at a scientist who decided to ask some awkward questions, but the way that he thinks about AI, he thinks about machines actually impacted our world immensely. So he definitely deserves a lot of credit, and he also changed the way that we look at things moving forward. This surprised me, and I'm curious if this is going to surprise you as well. So I was thinking maybe Copilot or ChatGPT's first GPT was the first large language model that we can ask questions and get response. However, I learned that it wasn't the case. The first large language model, the primitive version of it, was actually developed at MIT in 1964. This is to me is pretty impressive. Also, this AI program, ELIZA, passed the Turing test that I just mentioned you in the previous slide. So the testers were not able to differentiate the responses from machine to human. Moving forward, AI's development wasn't linear, so there's this very strange period between 1970s to late 1980s, which is called AI winter. So people were really excited about AI and they did a lot of investments. However, around these ages, it became something really questionable, or people started getting skeptical about the benefits of AI because they invested, they researched it. However, they weren't getting the benefits that they were promised when they did this investments. In fact, the British Science Research Council, one of the members said that in no part of the field have the discoveries made so far produced the major impact that was then promised. So because of this skepticism regarding the capabilities of AI, a lot of organizations cut the funding. It's almost frozen for that time of the timeline. And then later on, the machine market crashed because the cost of having these very expensive, very fancy, softwares or computer programs actually outweighed the benefit. So people invested it, but they weren't getting the benefit. They cut the funds, and then basically what we call this age is AI internet. Hopefully that makes sense to you. But AI rebounded. So in 1997, it gained its momentum. So IBM developed the first chess software, which is called Deep Blue. And Deep Blue was able to beat, in a chess game, it was able to beat the world chess champion Garry Kasparov. And this marked a very important milestone because in the history, this was the first time an algorithm in a very well-defined domain with computational power was able to outperform human experts. And now one of the questions that we are asking today is it going to keep happening to our practices as well? Well, this one is special for me. When I was looking through this, presentation slides, this is the best invention of AI to me. I think a lot of you have this in your home, and I don't think anything can beat this technology. So robot vacuums Well, I'm just half kidding, but half not kidding, definitely. I love them. Anyway, so yeah, iRobot made the Roomba, and I was thinking, yeah, of course, we have this vacuum cleaners for like, 5, 6, 7 years, I don't know. But when I look at the date, it's from 2002. So they have been with us for more than 20 years, and I completely did not realize that. And in 2018, the first version of GPT by OpenAI was developed, and the rest is history, right? So now we wake up to something new related to AI every day. It's changing by hour sometimes. It's really, really difficult to catch up with it. So when I put these together, I was like, okay, so we've seen a huge history. We started from the Greek philosopher. We went to, really high, shiny parts of AI, and then AI winter, and then AI coming back. And then I wanted to ask, what's next for AI? And I thought about it, I thought about it, and I was like, I have no idea. I don't know what's coming. I don't know if AI experts know. I don't know if AI is gonna gain a conscious and start killing all. I don't know. Maybe it's just gonna die. Maybe it's gonna be something like, maybe we're gonna have second AI. I have no idea. So that's why I decided to ask a different question, which is what we can do with AI, right? Because that's something we can have power on it, and that's something we can answer, and that's something we can actually shape. So how have we been using AI at MnROAD? So for us, for our unit right now, it's not a theoretical framework. We actually use it in a very practical ways. And Dr. Bernard will be here shortly to show you those examples. It is really great. While I'm concluding my, remarks, it's amazing. However, it's really important to make the point that we need to use it responsibly, intentionally, and we always need to verify. We can never let it, replace our engineering judgment, researcher judgment. It's a great tool, but we just need to be aware of the dangers of it as well. So from me, that's all. So thank you.
Is Raul here? Dr. Raul Velasquez? Please stand up. Dr. Amin Zadeh Ali. We don't have links to it here. We don't have links. Can you hear me now?
Yes, yes.
Okay. But I just want you all to give these wonderful engineers a very great round of applause. It makes the rest of us look good. This is my team. Thank you very much. All right. So when you hear of MnROAD data, think of the nebula that overwhelms anybody who has to analyze those data for papers or to answer questions here and there. AI to the rescue. Now, here is a time history of some volumetric water content. Imagine what it would have taken us if we had to do this just analytically. AI helped us here. We used large language model and got this time history. This is something that revealed a lot of things to us. So we can see here that there is a great relief in terms of faster delivery, which is one of the things we need, because there was a time around, I would say 6 years ago, we noticed that there were some papers that were coming from, especially I'll be very specific, from China on AI. And some of us did not know how to evaluate those papers because we needed to learn things like ground truth, AI arithmetic, like Kubert-Leibler, and like confusion matrices to actually be able to evaluate those papers. So a lot of committees were hamstrung. Committees are theory, but it's as if we caught up very quickly and we are dictating the pace, I would say. And that's one thing I would mention. So computational power is and quickness in delivery. We're able to now meet more needs because of the quickness. This is a great example. If you were to do this analytically, just the way without the assistance of the large language model, it would have taken an extremely long time. And this is where a lot of people fall flat when we get into the statistical representation of things. Now, here's the cumulative density function, and we're able to generate things like that very quickly because it helps us see data from a probabilistic perspective. Most of our world is not deterministic. Most of it is probabilistic. And being able to use large language model to convert things, data, whether continuous or discrete, into probabilistic form, where you can now have either a cumulative or a probability density function. There's a lot you can now do with this, and I will get into that. We did a paper recently, and that paper is being reviewed by the Transportation Research Records, the publisher for the Transportation Research Board, who's SAGE. And in that paper, what we looked at was a myriad of temperature measuring infrastructure at MnROAD. Now, when someone hears about instrumentation at MnROAD, let me put it to you. The cost of a pavement, of a test cell, the actual pavement material, is usually outweighed by the cost of sensors, the cost of installation of the sensors, the cost of monitoring and all that. So sensor installation is a big deal. So we are optimizing. We're looking at the temperature measuring infrastructure and seeing how we can optimize, how we can use optimum resources to still measure temperature and get things like maturity and get things like freeze-store, get something like freeze-store cycles out of this data. So what we have here is, you see some bars. Those bars are Kubat-Leibler divergence numbers. Kubat-Leibler divergence is an AI measure, it's an AI tool for evaluating how data differ. In other words, if you have a distribution and another distribution, think of the work done in moving from one distribution to the other. It's like an entropic approach to analyzing different distributions. So the Kubat-Leibler method is pretty rigorous. I mean, if you take all the data, first of all, you have to get the normal distribution and then get the probabilities from normal distribution and do an array and do the various equations. Tambora said I shouldn't have equations, so that was actually the Kubat-Leibler equation here. But at the end of the day, the ability to do it, especially in a batch mode, in this particular paper, the number of Kubat-Leibler analyses that were done was 1,500. If you do one and you do it correctly, just with Excel, it takes you like half a day, just one. We're able to do 1,500 so that we can make sense out of the data we have. So these are the kind of things that we can do. And these are examples of things that can be done as well. It's not just temperature infrastructure. To be able to view the data, could be some other, if something comes from below test at MnROAD, or you name it. We have a myriad of data types. Okay. And another thing we looked at the pavement uniformity. You know, pavement uniformity is a very vital aspect of concrete. Cannot rule out uniformity of base in concrete. So we were able to strategize in order to come up. We have two published papers now on this, on pavement uniformity, where we were able to show the effect of uniformity. So we used large language model here, and it enabled us to work faster and more efficiently. Now, this is an array that shows you the correlation between various sensors, according to Raul Velasquez. See, this array will give you food for thought, not just the array that you see here, where you can see all the information. Think of array from a larger perspective. You know, if you want to do something like a location allocation solution to a location allocation problem, which is typically called the transport problem, at times it's called the logistic problem. And that logistic problem solution started during the Second World War with Izevbekhai and Koenig. That's the reason why they call that solution the Hungarian algorithm. Those two guys were Hungarians. Okay. Now, there, instead of this array, you will have matrices. You know, in order to solve the location allocation problem, there is a whole list of manipulation of the columns and the rows that you have to do to get to an optimal solution. Large language model was able to accelerate, you know, the location allocation problem, the solution to the logistic problem or the transport problem. So with arrays in whatever form, another area that I will mention is the Markov chain. We did a paper in the Ph.D. conference. Markovian analysis can be very complex because you are multiplying matrices. And I was able to show how the terminal matrix for the performance of certain cells at MnROAD using the Markovian analysis. Now, in batch mode, AI has helped in being able to achieve that computation so that it's not as rigorous as it used to be. When you're multiplying like 10, because you have to multiply the state matrix by the transition matrix to get the current matrix. And then you can get the terminal matrix by multiplying a matrix, a condition matrix by the next one and set up a set of equations, because at the terminal, there will be not much change by the time you do that final multiply. And by rigorous arithmetic, you can now find out what the terminal matrix will be. So these things are very complex when you have something like a 20 by 20 matrix. That we have been able to use artificial intelligence to accelerate that. If you are doing, we've used it also in geospatial analysis, where we do the semi-variogram analysis. And in the semi-variogram analysis, we have the seal, we have the lag, we have the characteristics that give us your geospatial data set, and you can have a characteristic of how we found that useful in when we're looking at the influence of the position of various. It was NRRA, where they were looking at the effect of the distance from the actual point of measurement. And then we also use it for design, for the influence of setting, I believe, strain on I think it had to do with strain. I can't remember exactly, but we did that at MnROAD. That paper was done by Kazanovich, but we didn't use large language model. That preceded large language model. But right now, we are able to use large language model for geospatial analysis. And one thing I also do, ground truth validation, there's something called the confusion rate, ground truth validation. If you see the arrays you have there, these are all measures. Now, the first 6 blocks there, you see, top left, are input values, where you have true, negative, you have the total data, and then you have false, positive, true, positive, false, negative, 2 negatives. What usually happens is that those are the things you use when you are comparing discrete with continuous data. We have using to compare the profile. John Chan, shout out to you. Is this still here? Oh. All right, here's the author of profile. So now I'm mentioning profile. Now we have the automated fault verification in profile, and the automated fault verification. We're trying to compare the product of the automated fault verification to the ground truth, which is our fault measurement, our fault meter. Okay, and in doing that, we use this confusion matrix And it makes life really easy when there's a set of solutions we're able to get in one of the cells. Okay. Now, there are some national perspectives which I think I can mention. There's a published data, there's a published report from NCHRP already that shows the implementation of machine learning in state utilities. So NCHRP report 112, you find that. And then I'm a member of a NCHRP task force on how AI can improve data quality. You know, we're interested in data quality because if you have, for instance, you want to identify influential data, use whether the share and use Cook's distance. There are many other methods you can use. But the bottom line is that there has to be a way. But if you have a very large data set, like something coming from MnROAD, it's going to be very rigorous running share or running Cook's distance for each of the data. So even if you find your influential data, I'm very careful to use the term influential data because it doesn't become an outlier until you compare it to some form of institutional standard. So it's influential data up to a certain point. And once we identify influential data, we can now ask whether the data is, or the data point is it's an outlier or not. Now, let's not forget the person in the loop. In all these things, we are still master of work. We train the model. We do well to train the model. Now, look at this stepwise regression and the array. I wanted to do a stepwise regression. Look at the dependent variable, there is resistivity, and the independent variables are all the other variables in that array. Now, that's extremely long. It's not just what you see there, but just to show the array. Okay. Now, when I did this about, let's say, 6 months ago, it actually identified all the starting variables as independent variables, as final variables. What a stepwise regression analysis is supposed to do is to use the adjusted R squared, not R squared. R squared doesn't mean anything. Doesn't mean anything. The adjusted R squared is the one parameter, one factor that will not improve when you keep adding to the model. If you keep adding to the model, adding variables, it will look good. And people just dump all manner of things and say R squared is 0.85, 0.99. But you only want significant variables in your model. Now, 6 months ago, I had a particular large language model too, and he said that all the variables there were significant. That's how it solved the stepwise regression. But I knew better. I went and solved so the person in the loop matters. So if you have a situation where you just dump it on AI without actually having a large amount of what you're looking for, you have lost that person in the loop. You have lost the control of what you have. And AI can handle hallucinate. So these are the things. So later, just a few days ago, suddenly it has been trained, and now it gave a significant model which would run with what we calculated directly. So it's able to now do the stepwise. But mind you, for 8 different variables, for 7 different variables, stepwise regression analysis does 7 factorial. 7 factorial analysis. For 8 is 8 factorial. So you can see the astronomical figure in terms of the number of iterations it does to combine with the dependent variable in order to give you the variables that are significant. You need those significant variables to know what is actually driving the dependent variable. So what I'm saying is provide your own interpretation. I had an instance, and I will mention this real quick. we're trying to develop a second order differential equation to see how the pavement response would occur. And we used the spring, the dashboard, and the mass to develop the equation. We threw it to large language model, and it was hallucinating with it. It came up, and at the end of the day, it said that that particular pavement is a great shock absorber. So you cannot take that interpretation. The second order differential equation, it solved it to one extent. It found a particular solution, but it stopped there. We need a particular solution and a complementary function. It couldn't give us both. So there has to be a person in the loop. So we cannot just throw things out there, but learning continues when we now give it a feedback and enhance it a little bit, and then it's able to do better next time. Another thing is when we requested for Shokoloviski's equation, and just to test it, Shokoloviski's equation is, head pressure, passive and active head pressure. It came up with the passive pressure. It did not mention anything about active. See? So, and then when we now tested it for that and said, hey, give us the diagram that rhymes with this solution, with this equation. He couldn't. But you have to train it and give it some more prompts and so on. So there is, you cannot rule out the person in the loop. We have to know what we're doing when we're using AI. So AI, there is the responsibility, there are ethical issues, and generally there are issues with hallucination and all that, but avoid the situation. I forgot to mention we started with Bayesian statistics, very vital. That's conditional statistics. There's the naive Bayesian in artificial intelligence, and in the naive Bayesian, you are assuming, you're telling the Bayesian, you are saying that there is independence, that there is no conditional statistics. So it's working against Bayesian. So it's a method used, for instance, your telephone identifies spam messages. It uses Bayesian, naive Bayesian, and it uses that, and then it's able to now say, well, this is this is spam call, and so on and so forth. So those are little measures, but we have to fine tune them. Another thing is the random forest. In random forest, what it does is that it takes portions of the data and analyzes the portions of the data. And in analyzing portions of the data, it now aggregates them, what they call bagging, aggregates the portions of the data, and at the end of the day, it gives you a model. You can't do that. You can't do that because in things like time series, you have to deal with ensemble averages or ergodic mean. Because if you take a sample in a time series, it's not like the overall, there's no overall mean. There's no part of the time series that will give you an overall mean. So that's why you have ensemble averages. But if you subjected that, like the time series data, to an LLM, because the random forest, it will be of no use to you. So we are the people in the loop. We have to maintain our integrity when using AI. Thank you. Sorry.
Take questions later. We're running out of time.
Since we're already at 5 o'clock, I just have a few things. First is one that thank you everyone for attending, especially our presenters for presenting. Thanks to Lauren, Lisa from. We do have a meeting, kind of a casual get together at Shirley today at 5:30. Address the details of the tactics.